Now that we've taken a look at round 8 solutions, let's take a look at round 9 solutions. Ascension. Ascension is the last weekly puzzle in the 2019 Spacechem Tournament. The challenge is to turn a random input of cobalt, nickel, and copper into climbing rope, flint, and compass cores, with a maximum limit of 3 nuclear reactors and no sensor reactors, and as fast as possible. The advantage of using 2 reactors is during score calculations it would be considered 4 times faster. There's a few things to know about this puzzle. Because both copper and nickel have a maximum bond limit of 4, you must involve fusion and fission to sort these atoms. Another thing is, the input and output ratios are not 1-to-1. Every 12 inputs, because Spacechem balances inputs in inputs of 12, gives you 4 cobalts, 4 nickels, and 4 coppers, but the output requires 4 cobalt, 10 nickels, and 6 copper. If you count the atomic numbers, this means that every 12 inputs will have 336 atomic weight, and the 3 outputs have a combined weight of 562. These numbers do not easily agree with each other. Now, each of these solutions are very unique, so I will go over them in reverse order of ranking. In 8th place is Csaboka. Csaboka begins by moving 12 inputs and feeds this input back into the first reactor. He then proceeds to split all this all the way down to hydrogen, outputting the waste into the omega pipe. This solution is very slow because Csaboka is grinding every atom down to hydrogen and counting back up to make cobalt, nickel, and copper. Once all the hydrogen from the first 12 inputs are processed, he repeats and inputs another 12 inputs. It is a solution though, so kudos for submitting a solution to one of the hardest puzzles in the tournament. With this, Csaboka comes in 8th place at about 600,000 cycles. Coming in 7th place is Counterpoint. Counterpoint's first reactor has a startup loop where he outputs some atoms to his second reactor. Let's skip that. Here's how his main loop works. He first tests the atom for 5 bond limit. If it is, then it has to be cobalt, and it gets outputted to reactor 2. It then does nothing for the rest of the cycle. Now, if it isn't cobalt, then it has to be either copper or nickel. These atoms will be left here, and then it'll get split. Now these atoms both split to 14 on the right side and either 15 or 14 on the left side. Element 15 also has a bond limit of 5, whereas element 14 has a bond limit of 4. Counterpoint tests this input for a 5 bond limit. If it's a 5 bond limit, the silicon is fused back into it and the copper is outputted into the omega. Otherwise, if it's only 4, then it has to be nickel, and then that gets outputted in the psi output for reactor 2 in a different location. Counterpoint's second reactor makes dimers of cobalt and nickel and outputs them in a sequence of 2 cobalt dimers, then a nickel, then 4 cobalt dimers, then a nickel. This averages out to 3 cobalt dimers per nickel dimer. The rest of the nickel gets made into compass cores. The third reactor uses all the copper to make flint. The third reactor uses all the copper to make flint, splitting 2 hydrogen off of the flint's center coppers. These are then used to turn the 3-to-1 cobalt-nickel input to a 2-to-2 cobalt-nickel input to make the climbing rope. For 2 grab bags of 12 inputs, which is 8 cobalts, 8 nickels, and 8 coppers, Counterpoint ends up producing 1 flint out of the 8 coppers, 1 climbing rope out of 6 cobalt, 2 nickels, and some leftovers from the copper, and he produces around 1.5 compass cores out of the remaining nickel. The actual split is 4 nickels to the third reactor for every 8 nickels used to make compass cores. The reason why this solution is slow is because the first reactor processes the inputs very slowly. It takes around 120 cycles to process every input. 120 cycles times 24 times 40 is around 115,000 cycles, which is actually quite close to what his score. So it seems that the main bottleneck for Ascension is how fast you can process the input. In 6th place is Lazy Comet. Hi! Hello, Lazy Comet. Let's dig into your solution. Lazy Comet's first reactor does a lot of things. He first splits the input twice, and then triple bond tests the result. Now, for cobalt, this will end up with nitrogen and calcium, which only has a maximum bond limit of 2. For copper, this will end up with oxygen and scandium, which also has a maximum bond limit of 2. These two are not picked up, so essentially this effectively tests for nickel, and he separates it out. Cobalt and copper fail to pick up the smaller atom, which is either nitrogen or oxygen. This gets split into 4 plus 4 or 4 plus 3. Element 4 is beryllium, and this gets fused back into the product. Then the reactor bond tests the remaining 4 or 3 for bonds. So beryllium only has 2 bonds, and lithium only has 1 bond. Anyhow, it separates the cobalt from the copper and outputs them to the Psi output. This top output goes to reactor 2. Reactor 2 makes sticks of 4 coppers and 4 cobalts. The first time, it fuses 2 coppers and 2 cobalts to make element 56, barium, and then splits it to obtain 4 nickels. This nickel is used to make the climbing rope. It outputs the leftover cobalt and copper to the Psi output. Afterwards, the next 4 coppers and cobalts, it passes all the coppers to the other reactor and bonds all cobalts to this nickel stick to make the climbing rope, and from there it repeats. Alright, now let's go to Lazy Comet's last reactor. So for Lazy Comet's last reactor, its input is 6 coppers, then 2 cobalts, then it repeats. The bottom input is just pure nickel, despite what the pipe says. The 6 coppers make 1 flint with 2 nickel inputs from the beta input. Then the cobalt dimer, which is waste, gets processed. It gets split to make a silicon dimer, then fused to make 1 nickel. This nickel is actually used to make the compass core with 3 beta inputs. However, it generates iron waste, and this is actually fused together and stored as Rutherfordium. Yes, you heard me. This solution actually makes a garbage stick and stores it in the reactor. So, I am very impressed. Per 24 inputs, Lazy Comet makes 1 compass core, 1 flint, 1 climbing rope, and stores the rest as waste. Lazy Comet processes inputs at exactly 101 cycles per input and needs 960 inputs, which is a calculated score of about 97,000, and he scores just under that. Coming in 5th place is Csaboka. Csaboka starts by making a stick of 4 atoms to sort with. To ensure the 12 input rule, he stores the first 8 atoms. His reactor fuses the unknown input into the nickel-tipped stick. The cobalt will make cesium with a maximum bond limit of 1. Nickel will make barium with a maximum bond limit of 2, and copper will make lanthanum with a maximum bond limit of 3. The resulting atom gets bond tested and split, each time being sorted to a different location, with the nickel being returned to regenerate the stick. Now, the nickel and cobalt get put into this reactor where it makes a nickel-cobalt polymer. The first time, it gets split into 2 and outputted to the omega output. Afterwards, it will repeat, and instead, it will make 2 climbing ropes, and then it repeats. Now, this lower reactor takes the cobalt-nickel piece and fuses the cobalt from this piece into the copper from here, and this makes barium, which is split to make nickel, and this is used to make the compass cores. The rest of the copper from the pipe get bonded with the remaining nickel from this little piece to make the flint. So for every 24 inputs, Csaboka makes 1 compass core, 1 flint, and 1.5 climbing ropes. This turns out to be a wasteless solution, as in no excess atoms are stored in pipes or reactors, but it is still a little bit wasteful in that it does overmake climbing rope. At 960 required inputs and 96 cycles per input, it's an estimated score of about 92,000, which is just about right. In fourth place is Blue-Eyed Rat. Now, Blue-Eyed Rat noticed that if you split the input, if you split any of these atoms twice, you will obtain, for cobalt, 3 nitrogens and 1 carbon. With nickel, you will obtain 4 nitrogens, and with copper, you'll obtain 1 oxygen and 3 nitrogens. Now, the thing that he noticed is that the middle 2 of these products are always nitrogen, being the lighter of the heavier split and the heavier of the lighter split, if that makes any sense. With that in mind, let's get to Blue-Eyed Rat's actual solution. Blue-Eyed Rat's first reactor takes 2 inputs and does the aforementioned fusion and fission magic to make sticks of nitrogen. With the heavier of the unknown outputs, which is oxygen and nitrogen, he makes radium, and with the lighter of the 2, he makes mercury. Radium and mercury is what ends up when you have 12 inputs and fuse all the unknown outputs together. Now, this all gets passed to the second reactor. The second reactor takes nitrogen sticks and fuses them to make nickel for compass cores and passes some nickel to the third reactor. Whenever there's a radium and mercury input, it gets split twice to make element 22, which is titanium, and element 20, which is calcium. These products get fused into the nitrogen sticks to make sticks of copper and cobalt. And when this happens, the very top copper and cobalt gets fused together to make barium. Now, the third reactor takes this and splits the barium to make nickels. These nickels are used to make the climbing rope in a pinwheel shape. The coppers get removed to make flint with the past leftover nickels from earlier. So with every 24 inputs, Blue-Eyed Rat makes 1 flint, 1 compass core, and 1.5 climbing ropes. Now, Blue-Eyed Rat also needs 960 inputs, but he processes 2 inputs per 107 cycles, so an estimated score about 51,000 cycles, which he scores just around. Now, in third place is Rezunes. Rezunes begins by splitting the input 5 times. Long story short, what this does is that he will obtain a hydrogen if the atomic mass is above 27. This process gets repeated 2 times, so in the end, this reduces the random input into a stream of cobalt and a stream of hydrogen. Rezune's second reactor makes nickel by fusing a hydrogen to cobalt and makes climbing rope. It then fuses hydrogen to cobalt either once or twice to make nickel and copper. The nickel and copper gets inputted to reactor 3, where it makes compass cores and flint. Now, Rezunes balances his outputs to efficiently use hydrogen without overmaking any product. However, for one of each output, he requires 20 cobalt and 22 hydrogen. This means that he will build up 2 cobalt waste for every 22 inputs. Now, 22 inputs per 1 output and times 40 outputs is 880 inputs. Rezunes processes his inputs at 56 cycles per input, so 56 times 880 is about 49,000 cycles, or just below Blue-Eyed Rat. Congratulations, Rezunes, for your novel solution and for obtaining 3rd place. And in 2nd place is ToughThought. Yeah, okay, so ToughThought's solution is a very complicated one. Let's try to piece this together. So ToughThought begins by fusing 2 inputs together, and this results in a range of atomic weight from 54, which is xenon, to 58, which is cerium. The curious thing about this range of atomic weight is that it has bond limits from 0 to 4. With this, he separates out xenon, cesium, and barium, which are elements 54, 55, and 56, and outputs them into the omega output. Lanthanum and cerium have bond limits of 3 and 4. Here, the bonders are used again to sort them and output them into the upper pipe. Now, due to how the inputs work, this makes a really uneven distribution of outputs. For example, in the first 48 inputs, there are 5 lanthanum outputs, 1 cerium output to the psi pipe, and 3 xenon outputs, 5 cesium outputs, and 10 barium outputs to the omega pipe. So obviously, this is heavily biased towards the omega side. Let's see how ToughThought deals with this. So with the psi output, both lanthanum and cerium both split to copper on the left side. Lanthanum splits to nickel on the right side, and this is used to make flint. The nickel is stored, and when it gets too long, it gets cut a little bit and outputted into the waste pipe. When the cerium is inputted, only one of the coppers is used and the other gets outputted to the waste pipe. Let's take a look at ToughThought's third reactor. If the input to this reactor is cesium, it will split into nickel and cobalt, and this gets made into climbing rope. If the input is barium, it gets split into 2 nickels and it's stored in this massive chain up here. If the input is xenon, it gets split into 2 cobalts, which is then bonded to this nickel chain and is used to make climbing rope. So, one problem is if there's too much xenon, then there's going to be a point where there's a input of cobalt and there's no nickel left to make any climbing rope. Well, here's the thing. There's about 2 times in this solution where ToughThought completely runs out of nickel and has no more nickel to make climbing rope with the inputted xenon. However, at these points, the next non-cesium input, which always makes climbing rope, is always barium. Therefore, there is never actually a point where he needs to special case out a xenon input without any excess nickel to react with. I'm sure this took a ton of planning to do. ToughThought wrote in his write-up that it was one of the most frustrating puzzles he's ever solved because of all the errors he had to find and correct. Still though, I commend you on your solution. Nobody else changed a triple random input into a double random input and another triple random input. ToughThought processes 2 inputs in slightly over 40 cycles. His limiting output is flint. Long story short, there's a copper-containing output about once every 3 outputs into this reactor. 40 cycles per output times 3 outputs per copper-containing output times 6 coppers per flint times 40 flint is 28,800 cycles. ToughThought scores almost exactly this. Congratulations on second place, ToughThought. It is quite the complex solution. So in first place is Brookios. Now, this first reactor, after setting itself up, only sorts atoms by bond limit. Cobalt goes into this psi output, whereas the nickel and copper get split and outputted into the omega output. So nickel and copper split into either 14 or 15 on the left side and always 14 on the right side, which is silicon. This second reactor takes the pure silicon input and makes 4 nickels from that, 2 of which is used to make the compass cores, and the other 2 which are passed to reactor 3. The phosphorus and silicon random input is made into a giant stick, and it gets all fused in except for the last atom due to the atomic mass limit of 109. This, if you do the math, this means that for every 12 inputs, the end result will always either be element 101 bonded to element 15, or element 102 bonded to element 14. Long story short, with a little bit of fusion and fission magic, it's always possible to make cerium element 58, which is then outputted to reactor 3. Now, the third reactor makes climbing rope from the cobalt sorted from the first reactor with nickel from the second reactor. The 2 ceriums get split to make 4 coppers, 3 of which is used to make flint. The last one is fused with cobalt to make 2 nickels, one of which is used to make flint and the other goes to make more climbing rope. So, for 24 inputs, Brookios makes 1 compass core, 1 flint, and 1.5 climbing ropes. The input gets processed once every 20 cycles, and with needing 960 inputs, this works out to a theoretical cycle count of about 19,000 cycles. I hope I've been able to cover these solutions in enough depth to make sense to even the novice Spacechem engineer, despite the complexity in each of these solutions. Learning from previous solutions is one of the best ways to understand what makes a solution good for certain metrics, and I hope to have made this process easier. Once again, huge shout out to Gwen and Gigigol for organizing the tournament, and a huge thank you to all participants and the Spacechem community for making this a possibility. See you next time.